Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 121, I chat with Martin Dornfeld of Surgex about AC power conditioning and management. So stay tuned.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for Home Theater Geeks is provided by Cachefly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded July 23rd, 2012. Episode 121, Power to the People. This episode of Home Theater Geeks is brought to you by Netflix. Watch thousands of TV episodes and movies on your PC, Mac, iPad, iPhone, or TV instantly. All streamed directly to you, saving you time, money, and hassle. For your free 30-day trial, go to netflix.com/twit. Hey there, Scott Wilkinson here, online editor of HomeTheater.com. This week's guest geek is Martin Dornfeld, senior engineer at Surgex, a company that deals specifically with AC power issues. Hey, Martin, welcome to the show.
Scott, happy to be here.
Thank you so much. Those of you who are tuned into the live video feed at live.twit.tv or logged into the chat room at irc.twit.tv can post questions for Martin, and I'll pass along as many as I can. So let's start with sort of the basics. What should people with a home theater think about or understand about AC power and what they need to do to protect themselves and get the most out of their equipment? I know that's a very large question, so take any of it you wish.
Sure. I think first and foremost, the most significant thing is to adequately protect yourself from surges. Whether obviously lightning strike being the worst case scenario. But any surges that are being generated, even from grid switching and things, can be very detrimental to equipment. Additionally, you want to make sure that you're protected from things like brownouts and overvoltage situations, which can also be very damaging to equipment. And then, noise filtering. Most AC, depending on where you are in the country, is going to be a little bit dirty. So having some good filtering to help address some of those things is definitely going to benefit the connected equipment.
Mm-hmm. I've got a question in the chat room about whole home surge protection, which is one of the issues I wanted to ask you about. But sure. While somebody asked it, Undermined is asking about that. He thinks it should be mandatory on new home construction, which I imagine you might agree with.
Yeah, well, when you talk about whole home protection, what you're really talking about is service entrance protection. You're talking about a device that's going to be placed in front of the service panel where, the power is coming into the building. And it is very effective in mitigating surge energy that would be induced onto the power cables feeding the house. So it definitely provides a benefit. However, as general thumb, you always want your power protection and your power conditioning to be as close to the connected equipment as possible. Because you still have, for example, if you had a lightning strike in your backyard, whatever you've got at the service entrance is kind of irrelevant. The electromagnetic pulse from that lightning strike is going to induce itself onto anything that basically it can find, including the AC wiring in your building, which is basically a giant antenna. And that's going to then still find its way to your connected equipment, not to mention the fact that the whole house protection is not going to provide any real power conditioning per se. It's simply going to divert the energy coming in through the service entrance straight to the ground rod. So in my opinion, I think it's a great thing to have some kind of a service entrance protection, but I would not rely on that as the ultimate solution for protecting your home theater or your home office or other areas of the house where you have really sensitive electronics.
Mm-hmm. Lawn Dog in the chat room asks, there are a lot of areas that have low voltage conditions. Does Surgex make anything that brings voltage back up to the proper levels?
Yeah, we do have products that do voltage regulation, and we also have, we have our line of UPS products which regulate the voltage, and also if you do have obviously a complete power failure, you're gonna have your power through the battery backup. One of the things to keep in mind when it comes to low voltage or even over voltage, where you have fluctuations, if you're within 10% above or below the 120 volts that we really want to have coming into the building, pretty much anything that you're going to have plugged in is going to be able to to live with that very happily. It's when you get outside of that 10%, that's where you're potentially going to have some issues with the connected equipment. The power supplies, even some of the older, some of the vintage hi-fi stuff, and I'm sure some of your folks have some nice esoteric equipment that they're very proud of. Even that stuff, it's gonna be okay with slight voltage irregularities. When you get outside of that 10% plus or minus, that's when it becomes an issue. And quite frankly, the first thing I would suggest that people do is, if you're having very vast swings in voltage, contact your power supplier and see if they can't address that, because it really shouldn't be that dramatic. But depending on what part of town you live in, or the willingness of the power company to actually come and help you out, that's where something like a voltage regulator would certainly make sense.
Now, it seems to me that a voltage regulator, that is something that takes whatever's coming in, and if it varies beyond that plus or minus 10%, brings it back to that plus or minus 10%, would be a pretty hefty piece of gear, especially if it has to routinely bring it up from a low power condition or a low voltage condition, because it needs to have some sort of way to essentially amplify that power.
Yeah, and it's basically you're talking a tap switching voltage regulator, and it's gonna adjust for the low voltage as well as the over voltage. But for example, if you have a low voltage situation and you have a voltage regulator that's now trying to make up the difference, you're actually it's going to pull more current to make that happen. So your meter is actually going to be moving a little bit faster, trying to make up for what's not there. So they are going to definitely be drawing additional power to try and make up for what's not there in an under voltage situation.
Huh. And if they're trying to draw more power and they've already got less power than they need, how does that work?
Well, they tap up, and the thing is too, if you get to a dangerously low voltage, a voltage regulator has its limitations as well.
Sure, of course.
So if you get down to a super low voltage, the voltage regulator is only going to be effective for so long before it starts having problems of its own.
Right.
In those types of situations, and we make products, and others do as well, but we have UPS products that have a voltage regulator that deals with the fluctuations at the onset of issues, to keep you within that margin of error. And then when you get beyond that, it actually does switch over to the battery, and then the battery is actually what's powering the connected equipment. At that point, the voltage regulator is completely out of the equation.
Right, exactly. Davnell in the chat room is saying that my answer to that is a 2 kilowatt full sine wave UPS. Works great. I bet it does.
Well, a pure sine wave, or dual or double conversion UPS that provides that perfect regenerated sine wave is definitely a great solution for those situations. The one thing that I will say is that you're safe on the hot, but if you're encountering surge events on a typical online UPS, you're still vulnerable given the components on the front end of that UPS that are going to be diverting energy either to neutral or to ground. So you're not completely covered even with an online UPS. And if I can just put a little plug, unless you have one of ours, because you don't divert the energy the way some others do. But no, you're absolutely right. A pure sine wave UPS with a with the dual conversion, that's an excellent solution to eliminate the voltage related issues.
Mm-hmm. Before we get more into UPSs, uninterruptible power supplies, which I definitely want to dive into, there is a question here from Ethan Fromm's sled, which is, what is the long-term danger from routine drops in power or brownouts, as we might say? Can you talk at all about what problems might occur in sensitive equipment like audio-video equipment if they're routinely exposed to strong undervolt conditions?
Well, it's the same. I mean, it doesn't have to be routinely. I mean, all it takes is one significant event and you're problems. Basically, what happens is when you have an undervoltage situation, a brownout, for example, and usually general school of thought is when you get to about 90 volts, that's kind of the problem, mark. And what happens is when the voltage drops down in the neighborhood of 90 or less, the power supplies of the connected equipment are basically trying to make up for the power that's not there. They're basically trying to find a way to pull in more power, and there just isn't any there to be had. And as a result, they will literally burn themselves out in the process of trying to make up for power that isn't there. And so whether it's a prolonged, one-time event, it can be very detrimental. And as you know, any kind of these electrical anomalies, brownouts, surges, overvoltage situations, I mean, some of them will it only takes one opportunity for some serious damage. But even if it's lower level issues that the devices are exposed to, it's cumulative. And over time, it's just going to degrade the equipment. It's going to cause the equipment not to realize its full life expectancy.
Shorten its life, in other words.
Absolutely. That's really the biggest danger. Certainly, and not just that, but it can compromise the performance of the equipment. But ultimately, you're basically you're doing damage over time to the equipment. So it's not gonna be happy for as long as it would otherwise be.
Yeah. I've been talking about this recently with regard to projectors specifically, and the lamp inside the projector, of course, which gets very hot. And if you have a blackout, if you have a sudden power loss, the projector is unable to go through its cool down cycle. And so that's going to dramatically shorten the lifespan of the lamp itself, much less the electronics in the projector, which argues for a UPS. On projectors anyway, so that if the power goes down, they are supplied with enough power for long enough to at least cool down that lamp.
Yeah, absolutely. I mean, there are some projectors now that will facilitate that on their own, that they will be able to keep the fan running even if they lose power. But
they have their own little battery in them?
Yeah, exactly. Some of them do, and that's by design because of exactly what you've described. But short of that, a battery backup is key in that situation because you're absolutely right. A hot bulb with no fan to cool it off is not going to last very long.
No.
The other thing in mind though is that even without the power failure, I mean obviously the cooling is one issue that affects the lamp. But the other is that things like common mode noise and little transients and spikes and things that are happening on the AC are also affecting the filament in that lamp. And if you have dirty power, then the life expectancy of your bulb may be affected. So if you have a bulb, I mean, let's say you've never had a blackout, you've never had an issue with the fan cutting off prior to the bulb cooling down or the lamp cooling down. You're still potentially, if you have a bulb, let's just say that's supposed to be good for 1,000 hours as a round number, and you're only getting 600 hours out of it. Chances are that you've got some power-related issues, noise in particular, that's affecting the filament in that bulb and causing it to not realize its full life expectancy.
Well, I've actually been talking about that as well. One of our reviewers, David Vaughn, has been having some trouble with longevity in his lamps that he's basically gone to half brightness at about 400 or 500 hours. I'm not sure it's power related in that case, because he says the previous projector that he had went about 1,900 hours, almost 2,000 hours before it got to half brightness. But I will suggest that he take a look at his power and see if it's clean. This brings up a point that I wanted to talk to you about, though, which is the AC coming out of the wall is supposed to be a nice, clean sine wave, right?
In a perfect world, sure.
Yes, but it rarely is. In fact, it's got little bumps along the sine wave, which are noise on the line, as you referred to. Don't the power supplies of most electronic equipment filter some of that out, or do you really need something on the front end before the power actually reaches that equipment to do more of that filtering?
Certain power supplies absolutely do reduce the line noise, and will to some degree mitigate some of the issues, but not everything is created the same way. So certain devices, you're going to have a better result in terms of reducing the noise just through the power supply itself. Mm-hmm. Other devices, not so much. And we've seen time and time again where there is definitely dirty power coming to a system, and one would think that the power supplies within some of this equipment would mitigate the issues, and yet there are still issues. And by putting a good power conditioner or filtering device ahead of it, it actually does have an impact on the noise that's actually present in the system. So while you're absolutely right, certain power supplies will, in fact, reduce line noise. There's still a value to having a good power conditioner on the front end.
Mm-hmm. Virgil in the chat room asks, should homes have lightning rods as a standard feature? I'm not sure here in California we would need them, but in other parts of the country it might be a good idea, huh?
I've got one on my house. And,
really?
I think it's a good idea. I'm in Pennsylvania, and in the summer months it gets very hot and very humid, and it's very normal for even today. As I was joking earlier before we started the show, it's like in the mid 90s right now where I'm at, and normally by about this time of the afternoon, you'll have a thunderstorm developing, and so we may actually get a real live demonstration.
Well, I hope not for your sake, but it would be kind of interesting. Have you got your computer on a UPS? Would we be able to continue at least for a few minutes?
Everything I have is plugged into a Surgex, so I'm pretty sure I'm good. But But no, a lightning rod absolutely makes sense. I mean, the idea is that it's the highest point on a building, so that when you do have lightning, if the lightning does happen to be in the vicinity of your home, that it ideally will hit the lightning rod as opposed to, hitting your chimney or some other part of your house. Mm-hmm. And the idea is that lightning rod will just direct that surge energy straight to the ground rod. And the thing that's important to remember with lightning rods is that you need to make sure you've got good, tight connections. If you've installed one 20 years ago, it may have a little bit of wear and tear, and there might be some rusty connections. It may not be as effective as it was the day that it was first installed. But I personally am a big fan of lightning rods, especially if you live in an area where you're prone to those summer thunderstorms, as we are here in Pennsylvania.
Right, exactly. I wanted to ask you about people who have a dedicated home theater room, such as myself. When I moved into this house, I knew I was going to have one, and I had a dedicated circuit. You go out on the wall outside your house, and you have circuit breakers or fuses on older houses. And I had the electrician install a dedicated circuit into my theater that was only there. And I wonder what you think of that. And in particular, how would you address grounding issues in such a system?
Sure. No, I think having a dedicated circuit is certainly a plus, because now you're eliminating the possibility of other things that would otherwise share that circuit, possibly interfering with what you're trying to accomplish with your home theater. As far as grounding goes, I mean, grounding that's a show in and of itself.
Yes, it's true.
I know some folks. I don't know how well they're known on the in the residential world, but in the pro audio world, people like Bill Whitlock and Bruce Olson. There's a lot of people out there that make a living dealing with nothing but grounding issues. It really depends. If you have, some people will they think they need a dedicated ground, for example, or a technical ground. And in all honesty, in a commercial environment, that's probably more likely to be a viable or necessary thing. In a residential environment, chances are that you either have a good connection to your ground or you don't. And the value of putting in a technical ground in a residence is really almost non-existent unless there's a really, really major problem with the actual building ground.
What do you mean by technical ground?
Well, basically, you have a secondary ground that's not tied to the primary ground. So you basically establish a separate ground rod, a proper isolated ground, which is also a very tricky thing to pull off because you're basically disconnecting everything in your system from the building ground. So you're establishing a new ground, a reference ground with its own ground rod driven into the Mother Earth. And now everything in your system is referencing that ground. But if at any point in time you do something that introduces the safety building ground into that environment, you've completely undone all the work that you put into developing this environment. So it's something that has to be done right, and all it takes is one little mistake to make it all worthless. And And in most cases, it's not necessary. Like I said, in commercial applications where there's a lot of, you've got all kinds of large, machinery and things that might be impacting your system. You might want to have a dedicated separate ground to just separate everything. But in a residential environment, unless there's something seriously wrong or there's some extenuating circumstances, I just don't see the value of it in a residential application.
Mm-hmm. How does all this that we've been talking about grounding and so on affect the issue of ground loops, which occur when there are several paths to ground usually within several pieces of equipment, and if those ground potentials or voltages aren't all the same, we can end up with ground loops, which is 60-cycle hum in our audio systems and scrolling kind of bars in our video systems. How can we minimize that potential or risk?
Sure. Well, you're absolutely right. I mean, a ground loop is the result. You basically have two separate grounds at different potentials, and now you're tying them together, usually with a signal cable of some sort, and you have a voltage that shows up on that signal cable, and it's being now passed from one ground to the other. I think probably the most example, I should say the example that I find most of the time is what I'm trying to say, is you have your home theater and you have a rack of equipment with all your processors, your amplifiers, everything that's basically powering your home theater. Mm-hmm. And then you've got, and that's plugged into one circuit. Now you've got another outlet on the opposite side of the room, and you're plugging in your powered subwoofer. Mm. So your powered subwoofer is plugged into an outlet that has a ground at a different potential from the system. Now, of course, you're having your system. You have to obviously connect the subwoofer to your amplifier, right? Or right. Preamplifier in this case, because it's a powered sub. So your signal cable going from your rack to the subwoofer is now providing that mechanism for tying the two potentials together. And what a lot of people have done to fix this problem, it's a very common solution, but it's not a good one, is they finally figure out what the issue is, and they go to the hardware store and they buy one of those little ground lifters. You know what I'm talking about? The little orange plug.
I've heard them called cheater plugs.
Exactly. You're basically eliminating the ground plug. It's the kind of thing you would use if you had a three-pronged, cord, and you're trying to plug it into an older home that doesn't have the ground pin, and that's the little cheater that you put on. It will fix the problem because you're basically lifting the ground, so you're eliminating the two different potentials, right?
Right. You're disconnecting the ground of the device that you're plugging in.
Exactly. And as a result, the noise goes away and everyone's happy. The problem is, by doing that, you've actually defeated the purpose of the safety ground being there in the first place. So you're potentially opening up the door for some problems in terms of protecting people. You know, if something came loose, let's say in that the amplifier for that subwoofer, if a wire came loose and somebody touched the wrong thing at the wrong time, they could get quite a shock because the safety ground has been basically disabled at that point. There are solutions that are far more effective. One is obviously to eliminate whatever noise is present on that interconnect, but the other is, if you're going to lift a ground, you're much better off lifting the ground on the signal cable. So if you can identify where what is actually tying the two grounds together, there are devices, and they're basically, for lack of a better word, little tiny ground lifters, but they're designed for the signal cable. So you get the same effect, you get the same result, but you're not opening up the door to a major safety risk. So that would be and there are companies out there that provide, there's one that comes to mind is a company called Jensen Transformer. They have solutions for that. And that's, again, Bill Whitlock's company. He's very knowledgeable in these types of things. There are other companies out there that make solutions as well that'll do the trick. But that would be the proper approach. But yeah, ground loops and grounding problems. I mean, these are consultants whose names I'm mentioning who have made a living trying to hunt down, ground issues that, have literally they've been in facilities sometimes for weeks at a time, trying to figure out, where the hums and the buzzes are coming from. It's that's an industry all to itself, dealing with ground issues for sure.
Yeah. In my dealing with pro audio equipment, I have seen a number of pro audio gear that have a ground lift switch on the back that actually do sort of what that cheater plug does. Is that also a safety issue?
I'll be honest with you, I'm not that familiar with what it's actually doing.
Yeah.
If it's dealing with it at a signal level as opposed to a power level, then yeah, it has. And I guess at that point you're kind of taking a chance that the issue can be resolved from within that device, as opposed to being something that's further out. So it may be a situation where they say, hey, 9 times out of 10 or 8 times out of 10. By addressing it here at the signal level, we can fix it. There's always going to be those other times, the source of the ground loop is not something that you can address within that device. But as long as it's not lifting the safety ground from the AC, if it's dealing with things at a signal level, then that would be a similar solution to what I described as far as the devices that are available, to put on signal cables to address it at that place.
Right, exactly. What I did in my home theater was, as I said, I had a dedicated circuit just for that room, and I made sure that the electrician took all the grounds from all the plugs in that room and made sure they were all connected together and the same, so that when I plugged the subwoofer into one outlet and the amplifier into a different outlet, I would minimize the issue of ground loops. Did I get that right?
Yeah, I mean, the bottom line is if the grounds are the same, if there's no difference in potential, then you're not going to have an issue. So anything you do to ensure that the grounds that your equipment is going to be plugged into are going to be of the same potential is certainly going to address any potential ground loop issues.
Undermined in the chat room is asking a somewhat different question. How do the Surgex products work with PFC used on most modern PC power supplies? I'm not sure I know what PFC means. Do you?
No, I honestly don't.
Okay, well, Undermined, give us a clue what that means, and we'll get back to your question. I wanted to talk about UPSs, uninterruptible power supplies,
Yes.
which are basically big batteries that supply power if your main power goes out. Leo Laporte and I were talking about this on the radio last Saturday, and he mentioned that there were two types. One in which the battery is basically supplying the power and being recharged at the same time, and the other is the battery sort of lies dormant until the power goes down, and then it switches immediately.
Yeah.
Did he get that one right?
Well, there's actually three types of UPSs. There's a standby UPS, which is the most basic, which basically you're on street power. You're basically being powered by your wall outlet. When that power goes away, then you have the battery that kicks in and keeps the equipment running. Those types of devices generally have a longer switchover time, so that there could be a blip, some disruption depending on the equipment that's plugged in.
Mm-hmm.
The next level up is what's called a line interactive UPS, and that's a UPS that, among other things, incorporates some voltage regulation that will help to kind of, as you're having some of the voltage issues that are ultimately potentially going to lead to a complete power loss, you're already regulating that voltage. The line interactive UPSs also tend to have a much faster, switchover rate than an entry-level standby. Both of those are examples of a UPS that switches to battery when the power goes away.
Right.
The other one that you mentioned is what will be called an online UPS or a dual or double conversion UPS. This is a UPS where basically the AC is converted to DC at the battery level and then converted back to AC to power the equipment. So in a sense, it's kind of like you're generating your own power. It's almost like its own little power station, if you will. So and that's what's going to give you that pure, sine wave output. So you could argue you're basically running off of batteries all the time. And it's those batteries that are generating the AC that you're actually running off of. When the power is lost, you're still running off the batteries. The only difference is now the batteries aren't able to recharge. So once they run out, then you're basically, then you lose power completely. He is correct. Those are basically the two main approaches. Standbys and line interactives are they switch to the battery, and then you have your onlines where basically you're on battery power all the time. Regenerated battery power basically until you lose AC, in which case then the batteries can't recharge and they just run until they're empty.
Now, how long do UPS batteries typically last? I'm sure there's a range depending on how beefy the battery is, but I'm sure it isn't more than a few minutes generally. It depends, of course, on how much power you're trying to draw from them as well.
Oh, you're talking how long that they can keep something up and running, or how long they last before they
No. How much?
Okay.
Well, both questions are valid, but let's start with how long they can keep a system up and running before they run out of juice.
It really depends. I know our products. Depending on whether you're running a full load or a half a load. If you're trying to keep amplifiers up for, let's say, a public address system for a life safety application, that's going to drain the batteries a lot quicker than if you're simply trying to keep a digital console up and running. So, you're talking, depending on the load, 5 minutes to 20 minutes, from half to full load. But if you've got if you have something that has a very, very, very low wattage requirement, then you potentially could get 40 minutes, even an hour. It just depends on basically the wattage requirements of the equipment that you're trying to keep up and running. But most UPS manufacturers, ourselves included, we do offer on several of our UPS products expansion packs, so that if you calculate what the wattage is for the equipment that you're trying to keep up and running, we can tell you, okay, with the internal batteries on that device, you're going to have 5 minutes, or you're going to have 10 minutes, whatever the calculation comes to. And
Sure.
if you need to get to an hour, which in many cases that's sort of the threshold for life safety PAs. I mean, just imagine you're in a stadium and there's a complete blackout. There are stipulations that say, hey, in an arena or a stadium of that sort, from a safety perspective, you have to be able to do public service announcements and be able to communicate to people for at least an hour, even if you've lost complete power. So that's where you have to calculate how many expansion batteries might I need to keep that particular system up and running for the desired amount of time, whether it be an hour or whatever the requirement is.
Right.
But you can get there.
What about the other issue that you raised, which is the longevity of the battery sitting there? If you never have a problem, it's going to probably not last forever, right?
No, I mean, we warranty our products for 11 years, but we warranty our batteries for 2 years. So that should give you an indication that we pretty much think that they're good for about 2 years.
Right.
under normal circumstances. And we're not in the battery making business. We use standard issue batteries, but we warranty them for 2 years. In all honesty, the more a UPS discharges and charges the batteries, the longer they're going to last. So if you have a UPS that has never kicked in, like let's say you've got a standby or a line interactive UPS where you've never lost power and you've always been on the street power, and the battery has never had to actually power your equipment, that battery will actually last less than if your UPS actually went on battery power once a week, because discharging and recharging the battery actually is good for the battery. Believe it or not, it almost sounds counterintuitive, but that's.
Well, I have heard that, in fact, that cycling through a battery's power cycle really will help it last longer. So that's not entirely surprising to me. How has battery technology changed over the years? I assume we've seen improvements, lithium ion. I don't know what the latest technology is.
Yeah, there's many different varieties of batteries, and they all have their advantages and disadvantages. There's some manufacturers of UPSs that have proprietary batteries. We basically use standard issue, the gel pack. They're the lead acid, but pack batteries that you can buy any place. They're easy to get, they're easy to replace, and then whoever your battery supplier is, you can use whatever recycling programs they have to recycle those batteries. But there are different batteries out there, and but I think that's probably still the most popular battery right now in the UPSs. Like I said, I know some manufacturers have developed some proprietary batteries, but then the problem with that is when you need one, you can't always get it, and you've got to go back and to the manufacturer to get that specific battery for that specific UPS, and it's it's not always as readily available as you'd want it to be.
Mm-hmm. In the chat room, we got a bunch of people saying that PFC stands for power factor correction.
Power factor.
Yes, in PC power supplies, computer power supplies. Okay. How does that impact what you're doing? Well,
I mean, our products are designed to to provide the safest power to the connected equipment. Mm-hmm. And regardless of what's plugged into it, whether it's a DSP, a traditional desktop computer, laptop computer, or amplifier, whatever, our devices are going to provide the highest level of protection and filtering to that equipment. Whether it's a refrigerator or whatever. So I may not be understanding exactly what they're getting at, but in terms of what our products bring to the table, you're going to get the cleanest, safest power, regardless of what you plug into it.
Mm-hmm. Mm-hmm. Yeah, the question I just found it was how do the Surgex models work with PFC used on most modern PC power supplies? From what I gather, from what you're saying, you haven't specifically made products to address that particular thing. You're just saying, hey, you want clean power, you're going to get it.
Yeah, that's basically my response to that is our products are designed to provide the cleanest, safest power to the connected equipment, regardless of what's plugged in. So
right. Well, I got a bunch more questions for you, so please stand by for a moment while I thank our sponsor for this episode, which is Netflix. Of course, those of you who are watching the show here or even listening to the show after the fact know about Netflix. Most of you probably have Netflix streaming, which provides you with thousands of TV episodes and movies streamed directly to your PC or your smartphone, your TV, your Blu-ray player, your game console. Just about every consumer electronics device that has anything to do with audio and video has Netflix streaming. I wouldn't be surprised to see it in some refrigerators at some point in the near future. But in any event, you can use any of those devices to stream Netflix content directly to any device that has a display in it. So your TV or your computer, your laptop, your tablet, smartphone, just about anything. You can even start on one device and finish on another. It's the ultimate inconvenience for a mere pittance. And it's certainly what I use to catch up with series and other shows that I might not have on disc or might just want to watch once and not collect in my collection. So there's plenty of very valuable things to do with Netflix streaming. And for TWiT listeners, there's even a 30-day free trial. You can go to netflix.com/TWiT and just activate that 30-day free trial and check it out. And I hope those few of you who don't already have it will do just that. That's netflix.com/TWiT. And we thank Netflix very much for their support of Home Theater Geeks and the entire TWiT network. So, Martin, I wanted to ask you what you think about the claim, and there are many such claims out in the marketplace, that power conditioning, let's go from power protection, where we're protecting from spikes and brownouts and blackouts and so on, to power conditioning, which we mentioned a little earlier, of cleaning up that sine wave, as it were, how that might improve the performance, the audio-video performance of a home theater system.
Sure. First of all, in my definition of power conditioning, it's anything that you're doing to act on the power to make it cleaner, more stable, whatever. Mm. There are certain folks, when they hear power conditioning, they equate that to voltage regulation. In my opinion, they're two different things. Voltage regulation is voltage regulation. You could argue that it may be a part of power conditioning, but power conditioning is much broader than just voltage regulation. And a big part of that is filtering. And this is where my opinion is that no device is going to magically make your equipment sound better, including ours. Okay, if you have a system and it's being powered by AC that is dirty, or you have voltage issues that need to be addressed, then by getting the appropriate power conditioner in place, you can overcome those issues, and as a result, you're going to have better performance out of your equipment. It's going to last longer. And quite frankly, yes, you may notice an improvement in your sound stage from an audio perspective. You may very well notice an improvement in what you're seeing in a display. But the only reason that you're seeing that improvement or hearing that improvement is because we're addressing a problem that was keeping the equipment from realizing its full potential. You follow what I'm saying? So
yes.
So we're basically addressing an issue in order to make the equipment work the way it should. If you have good equipment and you have good power, then the amount of benefit from a power conditioner is going to be minimal. If you have lousy power, then the benefit from a power conditioner is going to be far more significant.
And is there any way for consumers to sort of test their power and see whether it's good or bad, and what criteria they might use to evaluate that?
Well, I mean, there's different things that you can look into. I mean, one of the biggest culprits affecting systems is common mode noise. And I mean, you can take a measurement if you had a voltmeter. You could measure to see what kind of voltage is present between the neutral and the ground. And if you
sorry, why don't you define common mode noise just so that we all are on the same page there?
Sure. Well, I mean, normal mode basically is what's happening on the hot in relation to the neutral. When you share what's happening on the hot with the neutral, now you have a secondary event that's basically on the neutral in relation to the ground. When we talk about, I mean, we can get into normal mode versus common mode surges, which is something a little bit different. But to just in its simplest terms, common mode noise is represented by a persistent voltage on the neutral measured against the ground or in relationship comparison to the ground.
Okay.
And it will and I'm on the more of a pro audio guy than a residential. So, sorry, folks, but
no, that's fine.
But in our environment, I mean, there are certain devices like video switchers in particular are very unhappy when they see a persistent voltage on the neutral. They don't like that. They lock up and they become very unhappy. Other devices will react similarly, and again, it's the common mode noise again is one of those things that'll affect, for example, the longevity of a projector lamp. So by cleaning up the AC, if you do have this dirty power, it is definitely going to have an impact on your system. As far as measuring it, like I said, short of getting out a voltmeter and seeing what's happening, you may not know that there is an issue there. But at the same time, I would venture to say that other than software issues, if you're having any kind of quirks in your system, or you're noticing something that doesn't sound right or doesn't look right, chances are that it's an AC-related thing that's affecting your system. So, looking into some sort of a power conditioner would certainly be a worthwhile thing.
Mm-hmm. I guess a voltmeter wouldn't tell you very much. It would just tell you in an AC situation, where the top and bottom of the sine wave are. What you'd really want to look at is something like an oscilloscope to see how much noise there is and that sort of thing.
Well, an oscilloscope will let you see what the sine wave actually looks like, and you'll be able to see things that are happening. So, I mean, if you have an oscilloscope floating around, you want to plug that in. A lot of people can go to the hardware store and get a little voltmeter, and you are able to make some determinations based on that. But you're absolutely an oscilloscope will also give you a visual representation of what's happening on the AC. And if you, unless you have a dual conversion online UPS, you're probably not going to have a perfect sine wave, no matter how good the stuff is that you're using on the front end of your equipment. And it's not always necessary that you have a perfect pure sine wave. A lot of people spend a lot of money to get a perfectly pure sine wave, and then they tell their friends about how great their sine wave looks, but it probably doesn't have that much impact on the performance of their system unless they had major problems to begin with. So,
Right. As you said, major problems to begin with. Cool Breeze in the chat room is asking a question back on UPSs, which is discussing replacement batteries, i.e. OEMs versus third party. I know that for projector lamps, for example, there can be a wide range in performance between an OEM or a original equipment manufacturer bulb that comes from the projector manufacturer versus one that comes from a third party. Is it the same thing true with UPS batteries? I mean, would a Surgex, or pardon me for mentioning the competition, APC or somebody else, a battery from the manufacturer do a better job generally than a third party?
I would say as a general answer to that question, no. Because, for example, we don't make our own batteries. There's only a handful of people in the world that make batteries.
Right.
Most UPS manufacturers are using a third-party battery to begin with. And it boils down to how good their supplier is for the batteries that they're putting in the unit when they ship versus the other alternatives that are out there. And I would say the same would be true for bulbs. I can't speak on behalf of the projector industry, but I would venture to say that a lot of manufacturers of projectors are probably outsourcing their bulbs. So
indeed.
Your OEM bulb is probably a third-party bulb right out of the box. So it really depends on how good was the supplier that they used versus how good are the suppliers that you have access to when you go to find a replacement. But it really just depends. I mean, go find a reputable supplier that you have a relationship with, and buy the best battery that they have to offer you that fits into the UPS that you're trying to replace.
I do know that in the case of bulbs, you're exactly right that third-party suppliers and OEMs both often get their bulbs from the same place, but the OEMs have tighter tolerance specs for what they will accept and sell sometimes than the third party. It may be the same with UPS batteries.
I would hope that a manufacturer that's getting a component from a third party is going to be very concerned about the tolerances. Right. I don't know that that's always the case with every manufacturer, be it projectors or be it surge protection. But I don't know that there's any. I don't know if there's any real evidence that one way or the other to support that. You're taking it on faith that whoever built your UPS took it upon themselves to put in the best battery that they could get their hands on. And I'm confident that in our case, that's certainly something that we're very concerned about is,
Sure.
our reputation for the products that we bring to the market. We certainly don't want that to be tarnished by putting in a subpar battery.
Sure.
But as you know, manufacturers they're looking to sell their products for as much margin as they can, and if they can save a few bucks by putting in a slightly cheaper battery, they might be inclined to do so. So I think it really just depends. It depends on a lot of factors. I understand the argument, and it's a reasonable argument to say that an OEM battery might be superior, but I just don't know that there's real evidence that consistently supports that notion.
Gotcha. Let's see here. Undermined found an answer for power factor correction.
Okay.
On your company website, surgex.com, the SU 1500 model apparently is designed with this in mind, according to the manual. So There you go.
Yeah, well, that's great. And shame on me for not being aware of that.
Well, you're an engineer, and I really appreciate your technical expertise, which is really what this show is all about.
Yeah, no problem.
Dr. T in the chat room is asking an interesting question about how green are UPSs. He says if you have 100 watts connected, does the UPS consumption is the UPS consumption 100 watts or more? And he mentions that older UPSs used to consume even when the equipment was off. Well, I suppose to keep the battery charged up.
Oh, well, that opens up an even broader discussion. I mean, depending on the batteries that are in the UPS, you could make a completely different green argument just based on the need to recycle the batteries. So that's a whole, you can, not just UPSs, but by and large, any piece of electronic gear, and it varies obviously depending on, what the device is. But every piece of electronic gear, even when it's powered off, plugged into the wall, if it's plugged into a live outlet, is still going to be drawing some degree of current, which is one of the reasons that we've introduced some of our, power management solutions where you can actually schedule to have, outlets physically shut off to cut power, specifically for the purpose of conserving energy when a device is not in use. Other things to keep in mind with UPSs, as I mentioned before, is that if you have a UPS, obviously you got to keep the batteries charged. So there's going to be current draw just to keep the batteries charged. And even if there's no load, as you know, a battery over time is going to drain to some degree. So even without a load, there's the need to have the batteries charging. But if you also have a UPS that's doing some voltage regulation, as I mentioned earlier, when the power drops below the threshold and the UPS now is engaged to do voltage regulation, regardless of what's plugged into it or how much what wattage requirements that equipment has, you're going to be drawing more power just to keep the power at that 120 volts if it drops below. So there's a number of ways that that could be an issue. I would say it's not just unique to UPSs, even though obviously with the UPS you do have the additional issue of keeping the batteries charged.
Right. And the whole issue of green also, and you mentioned what I call trickle power, or some people call vampire power, that even when the device is turned off, it's still drawing a little power. Yep. What about the problem of if you turn it off altogether, if you actually disconnect it from the AC power, as you said, with a power management system, you'd schedule it to go off. That could, for example, erase a little bit of memory that might be in it with the settings that you've established or the time and date and things like that.
Well, it depends on the device. There's volatile memory and there's non-volatile memory.
True enough.
There's memory that is subject to being lost versus memory that's going to be there. And again, if you have a complete power failure, you're going to be in the same boat. So obviously, if you have a device that has memory that would be jeopardized by powering it off, that would not necessarily be a candidate for that type of an application.
Right. Exactly right. Well, that brings. Sorry. Go ahead. Sorry.
No, I was just going to say with power management solutions, with ours in particular, everything being IP based now, there's also the ability to interact with the device itself. So if you have an IP based device, you can actually control what some of the functionality of that device remotely. So you can not just power it, not just cut the power, but you can actually have it power itself down and use its own internal software to ensure that that you're not causing more problems by just cutting the power. So there are different ways to approach that scenario.
Mm-hmm. You mentioned IP control, which is Internet Protocol, so you can control it from your computer or I'm sure your tablet or your smartphone in your house or even away from your house. That seems to me to be a trend for what is coming down the pike in terms of power management, power conditioning. Are there any others that you can mention?
In terms of future trends?
Uh-huh.
Well, I think power management is something that's really coming into its own, as of late. And yeah, there's a number of benefits. One is that obviously you do have the ability to eliminate that vampire power, phantom power issue that you described, and actually conserve energy in the process. So if you have gear that doesn't need to be powered, at a certain point in time, you can cut power to it and then have it automatically come up in time for the next showing of a movie in your theater or however you want to set it up.
Mm-hmm.
And of course, there's the benefit too of being able to get real time and historical information on kilowatt hour usage, so you can actually determine what benefit or what impact you're having by making some of these changes and cutting.
Oh, that's very good.
Yeah, and that gives you a really some tangible idea. The other thing is with power management, you're able, certainly with our products, you're able to get, as I mentioned, the current draw. You're able to get the kilowatt hour usage, but you're also able to get historical and real time information on voltage. So you can see if there's voltage sags or if you have voltage swells that are happening at certain points in time, and you can get that information and then act on it. So if you see that you are having voltage sag issues, maybe they're consistent or maybe they happen every night at 11 o'clock because there's some piece of equipment that's being turned on at that time. It's having an impact on the voltage. Now you're able to go and actually address that, and you have an understanding of what may be at play so that you can make an intelligent decision as to what you want to do to protect your environment. But absolutely, down the road, I think the main thing that we're going to see with these types of technologies is that they're just going to become more and more integrated with the other technologies that are out there. So you're going to see more apps. You're going to see more things that you can do from your smartphone, from your iPhone, from your tablets. You're going to get more apps, more flexibility. And I'm sure there's things that we'll be surprised in 18 months. Some of the things that are, but that's what I see. I see that we're definitely going to be more. All this cool power management stuff is going to become more integrated with other systems and a lot of the devices that you and I and everybody else is relying on every day now to just get through life.
Sure. Dr. T in the chat room asks, can you see the power consumption per outlet in a browser interface?
Yeah, on our products, you can. We have different levels of IP products, some of which have just basic functionality, but we have a product, the Access Elite, which does give you not only individual outlet control so that you can sequence them and do with them as you will, but you do get at the outlet level, you get the current draw information, you get the kilowatt hour usage information, so you're able to pinpoint exactly what's happening. I mean, we've had applications, for example, where we've had it installed in a certain environment where they wanted to have redundant amplifiers. So they had an amplifier plugged into an outlet, and then you could create a rule that basically said, okay, if the current draw ever drops to zero, which would imply that there was an amplifier failure, or either somebody turned it off, unplugged it, or it failed, but it should be drawing current and it's not. You could create a rule that would say, okay, if that current ever drops to zero, turn that outlet off because something's wrong, and then turn on another outlet that has a redundant amplifier plugged into it. So there's that kind of stuff you can do as well. But absolutely, it's that information is available outlet by outlet, so you can really do a lot of cool stuff.
Great. One last question. We're running out of time, but I really wanted to ask this question. What is the most devastating surge or power-related story you've heard?
Wow, I've been at this for a while, and I've heard of quite a few. One that I witnessed or experienced firsthand, and this was before I was involved even with Surgex. This is going back quite a while, but the house directly next door to mine took a direct lightning strike, and it did cause a fire within the house. Fortunately, it was a fire that was put out quickly, and for the most part,
fortunately didn't spread to your house.
Well, but here's the funny thing: even though the fire didn't spread, thankfully, and basically they experienced just smoke damage for the most part. The electromagnetic pulse from that lightning strike actually took out equipment in my home. So even though their house got hit, I lost a computer and a couple of other electronic devices just from being in the proximity of that.
Oh man.
Now, I do want to say that at the time, I did not have Surgex plugged in. I didn't have my stuff plugged in.
Well, and now you do, no doubt about it, I'm sure.
Oh, absolutely.
Great. Fantastic. Well, Martin, I want to thank you so much for being on the show. We've run out of time, a fascinating hour. And I look forward to seeing you at a trade show here and there, and maybe bring you back on in a while and give us an update on what's going on in power. Thanks so much.
Absolutely. Anytime. Thanks, Scott.
Thank you. You can read all about Surgex at surgex.com. That's surgex.com. My online home is hometheater.com, and you can email me at scott@twit.tv. Next week, I have two guest geeks scheduled. One is Matt Hirsch and Gordon Wettstein, two postdoc graduate students at MIT Media Lab, who are going to be sharing with us a new 3D technology that they've developed that does not use glasses. So glasses-free 3D TV technology of a brand new type coming out of MIT Media Lab. Should be fascinating, and I do hope you will join us for that. Until then, geek out.